All right, I think we're streaming. Just let me check if we're actually doing it. Okay, yeah. Just let me check. All right, yep. Yep. Okay. Well, it is. It is working. So, I have an update for you guys today. I'm feeling much better. Um, I'm feeling much better today. I had an accident. I met with an accident. Sorry for the English, but I met with an accident on Monday, on which is yeah, so 6th January. I met with an accident, and so that is why I was not able to stream for 3 days. But I'm back, but I'm feeling much better. Yeah, so I'm feeling much better. Um, if you want the details of the accident, well, I broke my collar bone. So I fractured my collarbone in a motorcycle accident. It was yeah, but thankfully it was not too major. It was not too threatening. So I'm very thankful to God that yeah, I'm very thankful to God that He saved me. And yeah, it was an incident, and but we move on. Um, and the grind should not stop. Um, so here I am again. So yeah, as I said, I'm very thankful to God that nothing major happened, and uh, and I'm still very good. So yeah. I just want to say that. So yep, that's good. All right, let's start. Yeah. So today we will be doing semaphores. So this is the semaphores. As you guys know, semaphores are the IPC mechanism to for shared memory, to basically synchronize shared memory between the processes or threads, and yeah, so basically it is used to synchronize the resources, the usage of resources between threads or processes. And it is it is a signaling mechanism, which means that if a process is using the shared memory or the shared variable or shared counter in this case, it signals the processes that it is using it, and once it uses it, it also signals that it's done using it. So that is using the wait and post system calls. So it does that, and between the wait and post signal calls is where it enters um, the critical section. So yeah, okay. So so yeah, that is what is semaphores. If you go through the slides, it's pretty simple. Mutex is a binary semaphore, as we know. And Semaphores kernel persistent IPC that can be used to synchronize between threads and processes. And there are two types: memory based and named semaphores, but it's typically implemented as a different IPC that has been less overhead than a semaphore. Typically, semaphores are counting semaphores, one per resource available. When all available resources are already in use, a process needing them has to wait until they're released. So essentially, it is um yeah. So it is signaling mechanism, and if you think about it, how many ever resources are there, and those many semaphores are in use. So depending upon number of the resources, the number of semaphores are constructed. So and this construction semaphores in pthreads, or at least in POSIX, is used is done by some minute function, which is here. I'll show you some minute. So you're declaring a semaphore, empty semaphore, a global semaphore here, and because there's only one resource here, you're using only one semaphore, and this is a shared resource because there's only one resource, so that's why you're using only one semaphore, and you're initializing the semaphore using the address to the semaphore, and this is 0 or 1 depending upon if the semaphore is shared between processes or threads, and this is 1 is and 1 is basically the initial value of the semaphore, which means here 1 indicates that the semaphore is available for use, and so the is available for use, and it's free, and it's not in use, right? So, and because we are using 0, this is for threads. If we use 1, it is useful for processes, and because this is 0, we are using threads for it, and that's why we're creating threads here. And we are defining a pthread create for the number of threads depending upon this counter, and this threads array, we have defined it here in yeah, we have defined it here: pthread, tthreads, numthreads. Numthreads is a global variable 5, and increment counter is the worker function of the starting routine of the threads, and you're passing in null as the argument to the thread function, which is this. The thread function, if you think about this, it should be void pointer, because I'll show you why. Man pthread create, if you think about it, look at the start routine function signature. It takes in a void pointer, and that's what it is, void pointer arg, and then start routine, and it's void pointer, and it returns a void pointer, so we are returning null here, and it is a pointer to start routine. Well, I don't think why is that, but because it is a pointer to the function, we do not actually need to uh, do um, write actually the pointer here. So that's the star function, the star symbol, we do not need to actually write it here, so that's cool. And okay, so and then wait for all the threads, and so if after it creates the threads, it will go to the increment counter. Increment counter will use the sem wait, log the semaphore, and then increment the shared counter, sem post, and semaphore again. It will unlock the semaphore and the number of increments. This increments is 1000, which means will it return 1000 because the shared resource is 0? I'm not sure, but yep, wait for all threads to finish using pthread join, and then finalize shared counter, and then you destroy the semaphore using some destroy, and then you return 0 because you're returning an int. So let's just see um, if we can run this. gcc q1.c minus o q1. So what is the warnings here? It says that it is deprecated. Well, self-destroy is deprecated too. Well, that's just a warning, but I'm sure it will work in other Unix systems. So let's see what is Seminit. There's no man for Seminit. That's insane. Well, so what is the alternative for in Unix systems? I'm not too sure about that. Let's see. Let's see. GBD. Semaphores in C in Unix. Let's be specific. Let's be Ubuntu. Let's say Ubuntu. Yeah, so these are the functions. Yep. Yeah, I'm using a Mac, so a Mac was maybe it is deprecated. I'm not too sure about it, but yep. So, it's the same thing that this ChatGPT also gave us. It's the same thing. It's actually the same thing. Counting semaphores, resource semaphore, decrement, post. Actually, you're doing 3 resources available on the same semaphore. Oh, okay. Okay, counting semaphore, 3 available resources. Yeah, and I got it. Got it. Yep. Nice. Why is there sleep though? Simulate some work with resource. Oh. Okay. That's cool. We'll see this if this works. I don't know why there's a warning, but it should work. Yep, as expected, it is 5,000 because the number of threads is 5. What happens is actually you're calling the first thread and you're incrementing a 2,000, and you're calling the second thread and you're incrementing another 1,000. So 5 threads into 1,000, so just 5,000. That's cool. What I would say in the slides though, so it says that differences between here, mutex needs to be locked by the same thread as that which locked it, whereas a semaphore is usually posted to by one process and waited for by another. Here, mutex needs to be unlocked by the same thread as that which locked it, whereas semaphore is usually posted by one and waited for another. That's cool because semaphores are not binary and they are a number. So is it locked or unlocked, or only 2 threads and cannot handle waiting for a condition? Allows both module exclusion, and wait. This also does oppose with support for like condition variables, hosting and coming loss. That's cool. Semaphores function calls, some open, I'm not too sure about this. Let's see what is sem open though. Sem close. That's sem destroy. I've known that sem destroy. Sem try wait. Sem wait. Sem post. Sem unlink. I'm not too sure about all these functions. So let's see what's there. Part of the which provides a way to synchronize access to your memory. Creates or opens a named semaphore. Okay. You can just use empty and you call it semaphore, I think. But the amount semaphore you can use. Okay. My semaphore flags the control operation or create OXL mode. This is used if you're creating the semaphore. As a semaphore, is of creating semaphore. This is the initial value semaphore. Sem close closes semaphore. That was open with sem open. You can just use sem destroy, right? Sem try wait. Decrements or locks the semaphore if it's available, or does immediately if the semaphore is unavailable. Locks the semaphore is available, or does immediately. Oh, so because this is a non-blocking um wait function for semaphores, I think. So sem wait converse will block until semaphore becomes available. That's cool. So you can use sem try wait if you want to return immediately. That's cool. Sem post increments reduces the semaphore signal that has been freed and the other process can acquire any sem post. Sem unlink, so it's no longer available for other process to open. Removes the name semaphore, unlink, and sem destroy. What's the difference between? I'm not really sure. Why is that? Oh, there's a producer consumer. I think they're using one because binary semaphore and using this, but you're using some weird so using a semaphore which is um, outside the global spectrum, which is some name my semaphore. Okay, that's cool. Some field is trying to access the resource, some wait, sleep, some post, some close, return. And this is the consumer, this is the producer. So some wait again. Actually, I think it's the same exact thing. Some open, which means it just consumes. So it just opens the semaphore. And if it is some failed, interesting. Some wait again, some post again, some close again. Interesting. Is some unlink and some destroy the same? Let's see. Oh, okay, it's not the same. They're used for different purposes. So you should remove name semaphore system. Is to destroy an unnamed semaphore. Oh. Okay, so this is for named semaphores. So using named semaphores, you need to use this. Understandable. So using named semaphores here. Okay, that's interesting. That's very cool. That is very cool. So we have learned a new thing here. So let's just semaphores nodes. That is interesting. That is very cool. So these functions are used for a named semaphore, and that's pretty cool. That's pretty cool. So is used for cleaning up name semaphores. This is to unnamed semaphores. It faces the research of a semaphore. It removes some of the name but doesn't immediately release some of the resources once all processes close it. That's pretty cool. Okay. Nice, 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 nice. That's pretty cool. What is the difference between sem open? I think it's the same thing for named and unnamed. What is the difference between sem open and sem init? Named semaphores, exactly. They used to create or open named semaphores can be shared between different processes. So if you want to use uh, semaphore between processes, then you should probably use semopen. Let's see if we can. Let's see if we just change this to 1. We'll just create a semaphore outside. Okay, that's. I don't care. Well, it did. It did not, but it's still dead 4998. Oh well, that is interesting. I don't know why it did that. I think if you want to do between processes, then you should probably use some open. Yep, mode or create mode and value on name semaphore is used with thread to synchronize with single process. That's pretty cool. That's pretty cool. That is very cool. So when you need a semaphore to be shared between the multiple processes. So for enterprise this synchronization, when you need an unnamed semaphore synchronize between threads within a single process, unnamed semaphores are faster and more efficient for inter-process synchronization because they don't require a name and are only valid within the process that created them. Yeah, nice. Oh, that's pretty cool. That is awesome. So it's just what it is. You just learn different things every day. Every day you learn different things every day. That's pretty cool. That is very cool. A name semaphores and name semaphores. How do you use? I have another question. How do you use sem open? How to use sem open with SHM? Okay, actually the same shared memory. So let's see. Interesting. God damn, bro. Next for producer, consumer, buffer. This is common.h. So you're including the common.h here. Oh my god. Open the shared memory using SHM open. SHM name is this. SHM. Okay. Alright. Oh, create ORDRW 0666 Set the size of shared memory segment. F truncate. Map the shared memory to the process address space using mmap. Damn, bro. Initialize semaphore. Producer loop. And consumer loop. Damn, that is that is insane. Oh my god. This is a completely new thing. So semaphores with shared memory. I think semaphores is fine. This is what we have seen because this is the shared memory. Mutex nmt and stored. Okay, it's the same thing that we have discussed earlier. Init, init, init again. There's mutex, which is for mutual execution. One max items is an empty max items. Because yeah, I understood. Because they are basically buffers, and initially all of the slots are empty. That is why max items is the initial semaphore value. Okay. One thing is for sure, like semaphores are allows both mutual exclusion and wait. It also does not lose a post, unlike condition variables whose signal can be lost. Uh, it is mutual exclusion and wait. Okay, not too sure about this. So can be used to provide mutual exclusion and implement waiting mechanisms, but the specific functionality depends on how you use the semaphore. It's synchronous technique used to ensure that only one process or thread can access a critical okay. Oh, so yeah, I understand. So mutual exclusion using mutex, using a binary semaphore, but also wait become true, which means that using counting semaphore, waiting, basically implementing waiting for some condition to become true. Decrements if the value is 0, the process will block until semaphore's value becomes greater than 0. Post increments the semaphore's value, the process waiting for semaphore and then it's unblocked. Resumes execution. Oh my god, that's pretty cool. So if you think about this, Peter create producers and consumers, and then you're joining producers, and then you're joining consumers, and you some destroy shared mutex, some destroy and empty shared and destroy, some destroy and stored, and then exit 0. That's pretty cool. The producer function, the consumer function. So the producer function is int I, for I is equal to I less than n items. You're waiting for the an empty. You're waiting. You're waiting if this n empty is greater than 0, which means there is an empty space. You're waiting until that condition. Only then you can produce. Makes sense. Then semwait mutex. Hold on, I'm using this mutex. This is for mutual exclusion. Share.buff. Okay, it is a ring buffer. I mod max items. Interesting. Um, why though? Why are we doing that? Why are we doing this ring often? Can we just do? Um, I'm not too sure about this line, but it's just an implementation choice, I think. Sem and then sem post shared empty, shared mutex obviously after doing that, and sem post and stored. Oh yeah, and then you're posting. So basically, you're decrementing the empty space you're using it. Uh, Given that it is greater than zero, and you're signaling, you're incrementing the stored variable that one more is stored, and the condition for it is that if it is and stored is if it is equal to max items, you you wait, and then once it is less than the max items, you add plus one to this. It's the same and the reverse for consume. Okay, some wait and stored. You're waiting until at least one, um, at least the end stored value is one. At least you're waiting until that condition, and you're decrementing it two. So you're decrementing the stored variable, so that you're basic because you're consuming that resource, and then you're doing some wait shared mutex. This is for mutual exclusion between producer and consumer. Cool. Shared buffer I max items not equal to I. Um, you are accessing. Yeah, basically you're accessing the buffer value there, and then you sem posting sem mutex and then sem posting an empty because one more is there for an empty. That's cool. Semaphores are typically kernel persistent IPC, but can also be file persistent. As in the case of memory-based spam, further implemented in shared memory, Semaphores can handle mutual exclusion as well as waiting for a condition. Yep, they're more reliable than condition variables. Nice. Shared memory introduction. Shared memory is an IPC with least latency. What's there in shared memory though? Yeah, as such, I'm open all these functions, mmap and stuff. Least latency. You can use semaphore here, as I told you, but mmap maps a file or shared memory object into an address space of an object. So use mmap for shared memory. It's a utility for shared memory to provide shared memory between unrelated processes. Oh my god, start void start length prot flags int fd offset. Okay. Yeah, so you're bringing in the file descriptor into the address space of a process. Yep. That's cool. Yep. File descriptor you putting in intfd offset 0, and then the flags map shared prot read. What is this prot read? I don't know about it, but the size is my shared size, and start is null. Oh my god, that's prot read prot write flags map shared map private. That's It's the least latency shared memory. It requires more work from the user in terms of explicit synchronization. We use the function mmap to map a shared memory object to data space of the process. Unless explicitly moved through a system unlink call, the shared memory object is kernel persistent. That's pretty cool. Okay. Not too sure about kernel persistent, which means kernel persistent is kernel persistent means that, let me tell you, let me, yeah, here, exists until the kernel reboots or IPC object is explicitly deleted. Process means exists until last process with this object opens the object or exits. Nice. So semaphores are actually kernel persistent, and shared memory is also kernel persistent. Nice. Nice. That's it. I think the shared memory we have discussed. Oh, dude, we have done 35 minutes today. I think that's pretty cool. If you look at the shared memory, if you look at the semaphores here, but shared memory is this using the shared memory, but I really want to know about. I really want to implement this actually. So we will ask GPT to do that because the code is actually just here, and yep, produce function, the consume function, uh, it will actually give the correct code. That it gives the correct code, and then we can analyze the code together. So here's the correct code. I think the semaphore is producer consumer. How are we doing this though? Ah, that's pretty cool now. So look at this. Look at this. Look at this. So this is the mutex. This track empty slots in the buffer, track stored items in the buffer, the actual buffer, and the producer index, the consumer index. All right. Produce item share.in global standard variables, and then you're just doing this shared, and then you're just doing dot in is equal to 0 dot out. You're initializing that. Okay, that's cool. And then are you okay? That's circle buffer index. That is cool. That's cool. That's cool. That's cool. Dot in. You're putting in I there. Again, you're doing semi on empty. You're doing semi on mutex, and then you're doing the produce item, the critical buffer index produced, some post on mutex and some post on stored. Here's some wait on stored, and and then enter critical section consumed, circle buffer index again, out basically. You're accessing it, share dot out, just the index for the producer and consumer, I understood. And then share dot out is equal to share dot out plus one. Yeah, okay. Exit critical section, signal run empty slot is available. Some mutex and some post and empty. Alright, that's reasonable. Okay, join destroy. That's pretty cool. That's pretty cool. That's actually pretty cool. I love that. Shared memory. Let's just do shared memory at this point. As an IPC with least latency. Mmap, we know that. Mmap is this. Let's just read mmap, what mmap has to offer in the terminal. Let's see. Mmap into memory. That's cool. There's the address here, there's the length here, the protocol flags, and FT and offset. Oh my god. Pages not be accessed, pages may be read. Pages, so the protections, okay. Especially when, alright, our pages were not accessed, read, written, exec, okay. What are we using here though? Read and write. Nice. Nice. The flags, what does it signify though? So it's a type of map object, mapping objects and options and whether modification made to the map. Copy the page are private to the process or are to be shared with other sharing. Map anonymous. Map file, map from regular file, map fixed, map private, map shared. So what are we using? Map shared. Then what is length though? Is used by system to determine starting address. That's cool. That is not really my concern. My shared size though. Length. What is length here? What is length? Oh my god. Yeah, so causes the page starting at header and continuing for at most length bytes to be mapped from the object described by FT starting at byte offset. Okay, right. To be mapped from the object described by FT. So from the FT, you're mapping this to the of the process. Okay. Okay, interesting. Okay, interesting. So whatever the length and the offset here, um, you're doing that. Starting address of the mapping. Okay, all right. Yeah, that's pretty cool. That's pretty cool. Not gonna lie. Now let's see the code. Shared memory. Okay. SHM open you're using. Obviously you're using these to include functions. Include statements. SHM name. SHM size. Um, size is well open. You're just opening the shared memory, and then you're using mmap. Okay. Um, okay. SHMFT. Just this. You're okay. So you're basically bringing this shared memory into this 1.c process address space using an offset 0, and this is just creating a shared memory, and you're doing map shared, which means it should be shared whatever you have done. Prod read, prod write, SHM size null, And then if it's a map failed, then a map failed, write to shared memory. Str copy hello shared memory. That's cool. strcpy. Damn, bro. shmptr, which is defined by this. Okay. Okay. You are casting the void pointer into a char. Damn. Okay. Shared memory content. You're again reading from the shared memory just for fun. That is cool. And then on map, you're doing mun map, mon map, mu m on map. SHM size is 4096. Okay. Set size of shared memory. SHM empty. Okay. Oh, so you're using you were actually setting the size of shared memory using f truncate. Oh, let's see what f truncate does. Is truncate or extend a file to specified length. Nice. Nice. File descriptor. It takes in a file descriptor. This takes a path. Calls the file name a path or reference by file descriptor to be truncated or extended to length, bytes, and size. If the file size exceeds length, any extended as. Let's cut if the file size is smaller than length. Extend. So you're extending to length, bytes, and size. Extends file size. If the file size exceeds length, any extra data is discarded. Nice. If the file size is smaller than it is extended. Okay. That is pretty cool though. Truncate, strcpy, man map, shman link. Amazing. What is shman link though? From this shows to the shared memory object specify my name. From that name. Ah, okay. 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 Entire until the last file descriptor reference is removed. Amazing. So you're linking this name. Oh, you're doing SSM open. Is there SSM link? No, that's not there. That's cool. Yeah, that's pretty cool. What's this? Damn it. This is a little too. Oh, this is using advanced IO. I don't know why it's here though. Are we using SHM here? I'm sorry, are we using SHM in this file? I mean, no, we're not using it. This is advanced IO. This should not be here, but okay. Yeah, we've seen, for the most part, we've seen this. Yep. That is pretty cool. I think that's my time for today.